Assalamualaikum. My name is Fatini Amani binti Nur Hazbi, and today I'll be explaining about the anatomical and biomechanical of the ankle. So first I'll start with the anatomical. The ankle consists of the anterior talofibular ligament, which is ATFL. It runs from the anterior edge of the lateral malleolus to the talus bone. Next is calcaneofibular ligament, which is CFL. It connects the fibula to the calcaneus bone and provides lateral stability to the ankle. Then we have the posterior talofibular ligament, which is PTFL. It is located behind the lateral malleolus and it stabilizes the talus bone against the fibula. I'll go to the biomechanical of the ankle. So we have dorsiflexion and plantar flexion, the inversion and eversion, and also weight bearing and triabsorption. So the first one is dorsiflexion. Is when the foot points more superiorly to the ankle joint, and plantar flexion is when the foot points toward inferiorly of the ankle joint. The inversion is tilting the foot sole to the midline of the body, and eversion is tilting the foot sole away from the midline of the body. And then the weight bearing and triabsorption. So the subtalar joint acts as a shock absorber that helps to distribute forces generated by ground contact. And this function efficiently support the body weight and provide for locomotion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nadira Najwa, and now we're going to move on to the next slide, which is how the ankles attach to each other. So the first one will be the bone structure. So ankle bone structure is formed by the talus, tibia, and fibula. At the lateral border, it consists of articular facet of the lateral malleolus and the bony prominence of the lower fibula. At the medial border, consists of articular facet of the medial malleolus and bony prominence of the lower tibia, and at the mortise is situated. Superior portion of the joint is formed by the inferior articular surface of the tibia and the superior margin of the talus. Next, we move on into the ligament. Ankle ligament consists of strong collateral ligaments. The first one will be the deltoid ligament, which is situated at the medially. It consists of 4 parts from a triangle connecting the tibia to the navicular, calcaneus, and talus. And at the laterally, it consists of anterior talofibular ligament, ATFL, calcaneofibular ligament, and posterior talofibular ligaments. We move on into the muscle. The muscle consists of multiple compartments. The first one will be the posterior compartment. So the posterior compartment consists of gastrocnemius and soleus muscles. Is responsible for plantar flexion. Next will be the deep posterior compartment. It consists of muscle like a tibialis posterior flexor, digitorum longus, and the flexor hallucis longus. Its function for plantar flexion and inversion. Next will be the anterior compartment. It consists of tibialis anterior muscle and is facilitated for dorsiflexion. And last one will be the lateral compartment. It consists of peroneus longus and peroneus brevis, which is enable for inversion. Okay, now we move on into the next part, which is tendon. So, in ankle, there's content of several important tendons, such as Achilles tendon. So, Achilles tendons is a connect muscle into the bone and enable of movement. It's attached to the calf muscle to the heel bone and is allowing for walking, jumping, and running. Next will be the cartilage. So there is 2 parts of cartilage, which is the articular cartilage and fibrocartilage. So the first one will be the articular cartilage. Is a hyaline cartilage, covers the ends of the bone in the ankle joint. For fibrocartilage, is the addition of the articular cartilage, as I mentioned before, and the fibrocartilage is present in the form of ligaments and tendons around the ankle. Next, we move on to the last part, which is the bursa. So there is a couple part of bursa. The first one will be the subcutaneous calcaneal bursa. It's located between the skin and the Achilles tendon, just above the heel. Next is subtendinous calcaneal bursa, which is situated between the Achilles tendon and the calcaneus, which is heel bone. Next is the retrocalcaneal bursa. It's located between the Achilles tendon and the calcaneus. And next one will be the lateral malleolar bursa, found near the lateral malleolus, the body prominence on the outer side of the ankle. And the last one will be the medial malleolar bursa. It's located near the medial malleolus, the bony prominence of the inner side of the ankle.
So next, moving on. So I will be presenting the functions of the anatomical structure of the ankle. So the anatomical structure of the ankle are intricately designed to perform its function of weight bearing, providing the stability that allow for a wide range of motion and also facilitating the locomotion. Next, the first anatomical structure that I'm going to touch in this part is the bones. So the bones that are in the ankle, including the tibia and fibula, the talus, the calcaneus, the navicular cuboid, and also cuneiform. So the functions of the tibia and fibula was to form a mortise, which is a deep socket that securely hold the talus. While for the tibia itself, the tibia bone function to bear the most of our body weight, and for the fibula, it provides the additional lateral support. For the talus, it functions or works like a hinge inside the socket to allow your foot to move up in dorsiflexion and down in plantar flexion. And also for the calcaneus, it supports the talus and forms the heel of the foot. It plays a role in weight bearing and also to absorb the shock. And for the navicular cuboid and cuneiform, the function is to form various joints that allow for movement and the stability of our foot or ankle. Another anatomical structure that we need to know is the ligament. Ligaments are crucial for providing the stability to the ankle by connecting the bones and limiting the excessive movement. So there are two types of ligaments that we need to know, which is the medial or deltoid ligaments. These strong fan-shaped ligaments on the inner sides of the ankle will function to stabilize against the eversion, which is the outward rolling out the foot. While for the another types of ligament, which is the lateral ligament, this include the anterior talofibular, calcaneofibular, and also posterior talofibular ligaments. The function is to resist the inversions, which is inward rolling of the foot, which is the most common of the ankle injury. So next, moving on to the muscle. The muscle itself providing the movements and dynamic stability to the ankle. So there are a few types of muscles and tendons of the ankle. So the first one is the gastrocnemius and soleus, which is a calf muscle. It was attached to the calcaneus via the Achilles tendon. The tightening and relaxing of the calf muscles will enable the ankle to bend downwards and upwards. While for the peroneal or fibular muscle, its function is to allow the ankle to bend downwards and upward and also provide the lateral stability to the ankle. Another type of the muscle we need to know is the posterior tibialis muscle. The function is to support the arch of the foot and also it enable the foot to turn inward. And the last one is the anterior tibialis muscle. The function is crucial for dorsiflexion, which is lifting the foot upwards, and also its function is to control the foot's position during walking. The ankle joint surface are covered with the articular cartilage, which is a smooth and a resilient tissue. So the functions of the articular cartilage is to reduce the friction and can also absorb the shock during the movement. Another type of anatomical structure is the bursa. Bursa is a fluid-filled sac that can reduce the frictions and cushions the structure of the ankle. For example, the retrocalcaneal bursa can reduce the frictions between the Achilles tendons and also the calcaneus.
Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. My name is Amisha Farahim binti Muhammad Faisal. So for this video presentation, I'm going to proceed with the physiology of muscle contraction. For this content, I'm going to share briefly about the muscle contraction of ankle at the anterior part, posterior part, lateral and also medial part of the ankle. Without any further ado, let's begin the presentation about the muscle contraction of the ankle. First, let's take a look for the anterior muscle of ankle. Anterior muscle of ankle is very functional for the dorsiflex the foot or raise the toes off the ground. First, let's take a look for the tibialis anterior, which is the main muscle on the outside of the shin that is used in walking to lift the foot and clear the ground. It is also commonly involved in anterior compartment syndrome injury. Second, for the extensor digitorum longus and extensor hallucis longus, it dorsiflex the ankle and extend the toes. Therefore, the muscle is used in walking upstairs to ensure toes clear the step. And lastly, for the fibularis peroneus tertius, it dorsiflex the ankles and everts the foot and lifting the lateral part of the foot off the ground. Secondly, for the lateral muscle of the ankle, as we can see on the diagram, there are two muscles that attach on the lateral side of the ankle, which are peroneus longus and peroneus brevis. So, the peroneus longus and peroneus brevis are on the lateral side of the ankle. The function of this muscle, the plantar flex, which is raising the body on toes, and everett, lift the foot sole outward, and ankle. It is very function during walking on uneven surface. Therefore, it also can prevent excessive inversion, which is turning inward of the foot, as our foot, human foot, is naturally prefers to invert. For the posterior muscle of the ankle, which is the muscle attached at the back side of the ankle, there are three muscles that are attached, which are gastrocnemius, soleus, and also plantaris. Let's take a look for each function of this posterior muscle of ankle. First, for the gastrocnemius, is the largest and superficial muscle that attach on the ankle. It used to propelling, walking, and running, and is also commonly injured in the tennis and basketball sports. Second, for the soleus, soleus is used to maintain upright position in standing joints with the gastrocnemius to form Achilles tendon and plantar flex the ankle. So, as we know, when we have any injuries occur at our Achilles, we have the difficulty to stand up. This is because soleus join with the gastrocnemius to form Achilles tendon that used to maintain the upright position in standing. Lastly, for the plantaris, so basically plantaris is lie between the gastrocnemius and the soleus. However, in some research, it says that this plantaris muscle absent in 10% of people, and also plantaris is used to plantar flex the foot. Furthermore, on the posterior side of ankle, there is also the deepest ankle muscle that's called tibialis posterior, that's used to support the foot, plantar flex the arch, and inverts the ankle. Plus, tibialis posterior also can be used to assist us with pushing down our car pedals. Therefore, to be easily explained that tibialis posterior help us during our driving as we pushing down the car pedals. And lastly, for the muscle contraction of ankle, on the medial side of the ankle, there are two muscles that attach to the ankle, which are flexor hallucis longus and flexor digitorum longus. Firstly, for the flexor hallucis longus, it used to bend the big toe when curling the foot, and it helps in pushing off during our walking. Secondly, the flexor digitorum longus can cause the toes to grip and adapt to the surface, and it's a very crucial function for balance on rough surface. Thus, walking barefoot on uneven surface is very beneficial for strengthening the flexor digitorum longus muscle. So, flexor digitorum longus help our toes to grip on the uneven surface so that we can keep our balance on the rough surfaces. That's all from me for my part. Thank you.
I'll continue with the anterior part of the ankle. So, in the anterior ankle, we can see the distal tibia and fibula, the lateral and medial malleolus, the talus, the tarsal bones, which are the cuboid and navicular, the cuneiforms, which is the first, second, and third cuneiform, the metatarsals, and also the phalanges. The anatomical part that can be seen in the posterior ankle, including the distal tibia and fibula, the talus, and also the calcaneus. Next, the anatomy of lateral ankle. We can see the distal tibia and fibula, the posterior and lateral malleolus, the talus, the subtalar joint, and the calcaneus. I'll move on to the radiograph of ankle. The first one is the AP, which is anterior posterior. In this radiograph, we can see the distal tibia and fibula, where the distal tibia and talus is slightly superimposed with the fibula. Then we can see the lateral and medial malleolus, and the tibio-talar joint space is open. And we can see that the talus is in profile. In this lateral radiograph of ankle, we can see the distal tibia and fibula, where the distal fibula and posterior half of tibia are superimposed, the domes of talus are superimposed, the tibio-talar joint space are open, and the calcaneus is in profile. So the last radiograph is mortise view. In this radiograph, we can see the distal tibia and fibula, the lateral and medial malleolus, the talus, and also the tibio-talar joint. So what makes mortise view different from AP? Where the mortise view shows the entire mortise joint space between the talar dome and the medial malleolus, the lateral malleolus, and also the tibio-plophon.